Hello, everybody. Thomas Beebe here with Advanced Data Tools. We're going to get started in just a moment. Um, just as a reminder, this is going to be recorded, so it'll also be available as a reference on the website and on YouTube in just a few days. Looks like recording has already started, so I am going to go ahead and get going here. So thank you all very much for being on, and thank you for anyone who is watching this after the fact. Okay, just a little bit about me. I've been with Advanced Data Tools for quite a long time now. I've been working with Informix for just as long. I do a lot of DBA work as well as development almost exclusively against Informix. I've also been an IBM champion for the last several years. My contact information is here if you have any follow-up questions after this webcast or you just want to talk to me in general. Thank you. So again, webcast is going to be recorded, so if anyone has anything that they miss or have to step away, you'll be able to watch the replay. Usually takes us a couple of days to get it cleaned, processed, and put up on YouTube. Please make sure your line is muted. Background sounds will distract everybody, so we appreciate that. If you have any questions, there's a little chat button. It was in the upper right. WebEx has moved things around a little bit, so should be somewhere on your screen. Feel free to put questions in at any point. If I see them, I'll get to them. Sometimes it doesn't pop up, in which case I will get to any questions at the end of the talk. So a little bit about this talk. The first thing is, unlike most of mine, I don't have a demo here. This is, and I only have a little bit of code. This is really focused on more of a theoretical, getting you thinking about how you can use ER for migrations and how you could leverage it to make your lives easier. I'm going to talk about some of the pros and cons, some different ways to use it, a little bit about some of the new features, but it's a little change of pace for me because I normally do a bunch of big demos, and this one I really wanted to focus on more of the theory. So where this came about is pretty much all DBAs at some point will have to do a migration. Whether it is you're swapping to a newer version of hardware, newer operating system. We have worked with many companies who are doing migration from an older Unix to a Linux system. We have some going from physical hardware to virtual, going to cloud. So you're changing something fairly drastic. If you're just upgrading Informix, you can usually do it in place. It's not a big, it's not a huge deal. But when you're migrating from, a HPUX system to a Linux system that's running on a virtual environment in the cloud, you're changing architecture, you're changing Informix version, you're changing everything that ties into it. There's a lot that goes on with that, and this can be very, very time consuming and very risky from an organization standpoint because you have only so much time you have, if any, for downtime for this migration. And we have to make sure everything runs smoothly and that you have a full plan, and you need to minimize downtime. You need to do everything you can to protect yourself so you don't lose data, you don't have unexpected problems, and you're flexible to make sure everything can be tested and checked out. Again, downtime is precious. ER can help you minimize the amount you actually have to be offline to effectively zero downtime for a migration. So the biggest advantage of enterprise replication is it allows you to do the data migration between environments that may not be, like. So some of this talk also, I did a talk a couple of months ago, so you can find it on the YouTube replays, about an introduction to ER. I'm going to make a lot of references to ER commands, ER concepts. I went into far more detail with each of them there. So if you're new to ER, go back. I would actually recommend probably watching that webcast before this one. If you're on the webcast already, just watch it later on. But I will be referencing back to that a fair amount, just with the different commands that enterprise replication does and some of the underlying underpinnings of how you actually do things. I'm going to talk more about then how you take those commands, take those features, and then actually use them to help your migration. So what is ER? Just the real brief overview is it is an asynchronous log-based replication for Informix. What this effectively means is it'll read through the logs, and then replay those transactions on any targets you may have. It's not the same as HDR replication, which is actually shipping over the change pages through the logs and also replicating everything real time. ER specifically meant so it doesn't have to be real time. It doesn't matter if your secondaries get behind. It doesn't matter if your outside systems are on a bad connection. It's meant to handle that. It's also meant to be far more flexible and far more version and operating system independent. The other thing is, you notice here Informix version agnostic. That is somewhat true. Technically, you could ER between version 9 and version 14 if you want to, and 90% of your code or your data will work correctly. But they've added a lot of new features, especially in version 11, 11.5 and 11.7 in particular, that if you're running older than that, just check your documentation. There's a few features that are not supported. Also, obviously, newer, you really shouldn't be replicating, from a 14 system back to a 9 system if you're running things like trying to store time series data or JSON data, or some of the data types that were added in and are not supported on older versions. Obviously, it can't replicate those. But for most of your data, most of the data types, so it's asynchronous. It doesn't need to be real time. It goes off the log, so it's replaying the SQL. The big important part there is because it's doing that, it's not relying on binary data. It's not sending everything in a binary specific format. So you can't, and some other types such as HDR, and especially if you're doing backup and restore, it's storing the data in a binary format. So if you change to a different operating system, you change from 32 to 64-bit, or even if you change Informix versions, the data is not going to be usable. ER, because it's handling it in SQL, is actually going to be usable for any kind of cross-system, which is when we're talking migrations, often what you're dealing and often one of the hardest problems. The nice thing with it also is it is not a entire instance replication. You replicate how you want, where you want. You can replicate a single database. You can replicate just set tables. You can replicate only parts of tables. So if you don't need to replicate everything, you don't have to. And you can also replicate how you want, so it doesn't necessarily all need to be the same way. So it is far flexible. Obviously, because it is flexible, it takes longer to set up. HDR, as we've shown in past ones, is very, very simple, very quick. ER is a little bit more complex, but far more open to whatever environment you may have. The other thing, and just to highlight this, and also very important for the rest of this talk, it allows for both update anywhere or primary target replication. So you could have it be where any system on the ER set can update a record and all of the other systems will get it. Or you can have it where it only goes one direction. So you have a primary and then you have a target. If the primary updates a record, it gets sent to the target. If a target updates the record, it just stays there. Depending on your environment, that may be a preferred way to do things. So reasons to consider ER for migrations. I mean, this is the crux of the whole talk. It allows for direct replication between different environments, regardless of operating system, regardless of Informix version. It'll let you basically transfer the data automatically between them. It allows you very easily to set up dynamic testing development environments. You can go and replicate your entire production environment to a second box on your new target platform. Set it up so it is, doesn't send changes back in, but then your developers can test all their code. You can test everything you have running on the new production box, on the new operating system, new Informix version, with your effectively live data without it impacting the live data. And if something goes wrong, it doesn't impact change anything else. You can do all your testing using ER without actually having to, take full backups and do restores. And, if your developers want a new copy, you have to go through the full process again. You can get live trickle feed or live feeds of data. There's lots of different ways to configure for that. It allows you to migrate without downtime. you can actually go in, set up your secondary your new system to be getting your live data, and then when you're ready, just cut over. And it's already got all of your data there. You've already checked it out, and you don't actually have to have any downtime past however long the switch takes. It's not the old method of having to use DB export on a terabyte database and knowing you're going to be 24 hours for the export, 36 hours for the import, and just crossing your fingers the entire time everything goes clean, or you have to start again. This lets you have everything ready to go, be verifiable, tested, and then just when you're ready, just flip the switch and you're up on the new system. It integrates with connection manager, so a lot of the connection manager features you may like will allow you to handle that. And there's some nice migration aspects involved in that. And the other thing is it allows you to keep your old system running, and you just cut over when you're ready. So again, you can have your old system ready to go. You don't have to bring it down. You could even have it up live until that moment of cutover. Again, most of the time, as soon as you start the backup process on a migration, the production system is then offline, and until the target is fully restored, you're totally down in the water. So this is a nice change to that. So other positives, supports all data types. Caveat there, a little asterisk, is version dependent. Earlier versions, even if the engine supported time series, ER didn't support everything. If you're on a newer version, on later versions of 12 or you're on 14, it'll handle just about everything that Informix has. It allows you to do time-based replication. So you can actually set it up to only send replicates every 30 minutes, or set it up to only send data on 5 o'clock on Friday, or 3 p.m. every day. There's a number of different ways to configure how and when your data is sent. You can also, with data, you can repair it rather than recopy it. So you can check to make sure your target is in sync. You can also tell it to basically update any rows that have been changed, rather than having to do the old method of drop the table, rebuild it, recopy all the data to make sure you didn't miss anything. Now one command, give it a little bit of time, and you will automatically sync anything that is out of out of sync with the primary. There's a whole number of new 14.1 features I am going to cover at the end. So a few considerations, though. These may be showstoppers depending on your environment. One, all databases and all tables that you are going to replicate, they need to be logged. So you can't be running this with raw tables. You can't be running this with an unlogged database. Again, because ER uses the logs to ship the information, everything has to be logged. All tables will need a primary key, a shadow column, or a unique index. So hopefully they already have primary keys. It's usually a good practice to do that anyway, or at least a unique index on them. If they don't have one of those, you can add a shadow column. That can be a little time intensive. I'll show you at the very end. I've got just the command to do that, but that is an option if you need it. You do need to have a replicate created for each table. There are some ways to automate this, but you can't just do a full database replication. You really need it is a by table situation to set up replicates. And the servers that you're going from, your old server, your new server, your testing server, whatever other servers you may have involved here, they need to actually have trusted host setups. So just make sure that they all can communicate and they're trusted for whatever direction the data is transmitting. So standard replication, just because we'll mention this a few times, this is just your standard ER replication. This is going for, and this is specifically for replicating a single direction. CDR define REPL, tell it the C, which is the conflict resolution, the S, which is the transaction, or is it looking at row or transaction based. Goes through, we're calling this one foo REPL, then P before the actual definition of the table or the source, which tells it the primary, and R is the replicate. So again, all these are in the ER webcast, so go back and take a look if you're new to ER or need to brush up on it. I just have this in here as a reference, just because we're going to be using this a fair amount. So this is standard single directional replication. This is really good for setting up a test server where obviously we don't want to have data feedback to the primary. It also may be a case where we don't want we set it up in advance and we don't want testing or anything else to accidentally send data back to our live production system. So you set this up, and so anything that happens on the target will not be replicated back to your original system. So it's safe to do that, to do things in advance, make sure you don't accidentally put test data into your live database. So you can use it straight for the copying. It's fine to do that. You can also use it for a drip feed. So, and when I say drip feed, I mean a slow moving of data. So you can do is set up your database, set up your copies. Maybe you have some of the data copied already, and then you set up a replicate and just let it send the data over as the data comes into the system. And then as you have time, as your network and systems have bandwidth and processing power, then you can synchronize and move over larger sets of data. That's a really good way to move a lot of your data in advance, so you're not having to do a whole lot of data transfer on time on the actual day of the the day of the migration. So to update anywhere replication, so this is, we want both sides to be replicated, and I apologize, I have a typo. It should not have the P and R in this case. I will have that fixed before we put these slides out. But same syntax, just doesn't have the P or the R in the statements, which again, please ignore that on this slide. And it just means that every connected replicate will actually, every connected target for the replicate will update as soon as it can when there's a change made on any of the systems. In this case, we're using the -C timestamp conflict resolution, in which means it'll go by whatever was the most recent update. It'll trust that is the correct one to do. So in case two sites update at the same time, whichever one is the most recent will be considered authoritative. There's a couple of different ways to do this, a little bit outside of the scope of the talk, but I just wanted to reference that Update Anywhere is very easy to set up and readily available. This is, again, really good if you're doing a slow move or you want to set up two systems to run in parallel rather than necessarily doing a full cutover. Or you may want to actually be able to send data back to the original system just in case. So loopback, I am mentioning this as a new feature, came in 12.1 XC11. It's been improved a bit upon in version 14. It allows you to actually set up an ER replicate to the server itself, so you can loop it back to itself. So if you wanted to, say, create a table for testing, you can do that. I don't have a really good migration case for this. You may have ideas for it. I just wanted to mention it in case it gets you thinking that, hey, I've got this situation where I need a developer to be able to play with this data without it touching the actual live data, but they need to constantly have updates. That's a really good case to use for that. And this may be something where you want to set up loopback data to do something with testing or you're part of your migration process. So I'm mentioning it's here in case it would be useful. So the old way of doing this, if we can't for this, is obviously DB import, DB export. Previous talk from us was Mike discussing migration. He's done a lot of work benchmarking different types of copy. The other way to do this, which is fairly similar to how we're doing it with ER, is doing SQL copy. So, insert into remote table, select star from local table. It's very easy to set up, and I wanted to really contrast between the ER setup and the SQL copy. And just because you choose that I'm going to do ER doesn't mean it entirely rules out SQL copy. You can use them both in tandem. So I wanted to highlight it here. So both are platform agnostic, which is why I really wanted to compare them. The SQL copy takes far less setup because really all you need to do is set up trusted hosts between the two and then just use straight SQL to do this insert into select star from, and it'll let you copy across. The SQL copy allows you to set a table in raw mode so there's no logs involved and then change it back. Obvious downside there is you can't turn it to raw mode if there's a replicate against it, if it's got a primary key enabled, if it's got constraints. So unless you turn the entire database into raw mode, in which case there's no way you can run any ER. But it's an advantage if you're doing just SQL copies. You can change the database to unlogged, or you can change the table to raw, and then you just bypass the logs, and it is faster. So on the other hand, ER is more flexible. Obviously, we can do the real-time data transfer. We can do the drip feed. We can schedule the data. We can have it only transfer some of it right now. We can only do it for certain parts we want to. It's a more flexible solution. It's a bit more reliable too, because obviously we have all of the pieces in place and all the great work that the IBM and HCL engineers have done, making an incredibly robust system. To all of that is then at your disposal to have this reliable source to get the data across. So depending on your environment, depending on how you're doing it, one, the other, or both may be the right solution. So again, ER can be restarted, scheduled, or continually sending data. The other thing ER will do that SQL copies will not is it allows you to send smart blobs. So if you've got blob or clob fields, ER will let you replicate those directly. If you're using SQL copy, you actually have to unload them disk, and then you can then copy them over from the files on disk. Or what some people will do is actually write a program that basically pulls them in and then sends them up to the new one. Obviously, it's a little trickier than going straight with ER and just creating another replicate. Also, if you're dealing with time series data or just standard non-relational data, ER is generally a lot easier to deal with copying it than trying to get it through SQL. Not that you can't do it through SQL, it's just usually a little bit more work. So we've contrasted those two, and now we're going to talk about a couple of different ways we can use ER. So obviously we're using it for data migration. That's the big way we're using it here. The thing is, you can either set it up so you have an initial, or one way to do it is to set up an initial set of data in advance and then basically keep your server up to date. So you copy it, whether it is if it's the likewise on, you're dealing with the same operating system, maybe you pull down a backup copy, you restore it over there, and then you just have a trickle feed to catch up the new system, because maybe you're going to a newer version of the operating system, but keeping on the same hardware architecture, or you're going to a vastly different version of Informix on the new system, something that wouldn't let you use other replication methods, or allow you to just straight import it normally. So you can load up the data however you want to. You SQL copy it, DB export, backup restore, however you may get the data, and then set up ER to just catch up for anything that's changed since that backup was taken. And what you do is you just trickle feed, you let the new data flow through, you synchronize as you can, and you're up to speed. So to actually set that up, to set up the entire environment, there's a few steps, not that difficult, doesn't take that long, but I'll tell you the first time you set it up, there'll be some hoops. Again, all of this is the actual how-to commands are in the ER presentation. So actually going through the steps of setting it up. So first thing you need to do is set up replication on all tables. So it has the prerequisites, needing your keys in place, needing to know exactly requirements for how you're doing the replication, but however you have your environment set up, you set up your replication on every table that you're migrating. You then need to start the replicates. At that point, and this is talking about a complete data transfer using ER, use the sync command to transfer the data. So I'll actually show an example of that in a moment. But the sync command will transfer everything from point A to point B. So if you need to copy everything over ER, that's a really good way to do it. After that point, after the sync is complete, it'll have everything flowing through on replicates, and assuming you don't change anything, you should now have your target fully up to date and staying that way. So it's ready to go for whenever you do the migration. Big thing here is if you have foreign key dependencies in your database, make sure to choose your table order based on that. Because what it will do is if you're just going down alphabetical order on the tables, you may synchronize one table before all of its foreign key required fields are in place on other tables. So make sure to know your data and know the order you need to transfer in. Obviously, on the target, you can always use disable constraints, even disable indexes in advance. I shouldn't say disable indexes if you're using a unique index that's required, but you can disable the constraints on the target and then re-enable them all after all the data is copied if you want to get around that and not have to trace out if you have complicated sets of foreign key requirements. So a couple of different ways to skin the cat, as it were. The other thing is if you're dealing with a primary that is active and you are not running real-time synchronization, you might need to do a few passes after you do the sync. What I mean by that is you may need to do a repair job if you are not leaving the replicates active, because obviously if you're moving one table at a time, and the system is still live, one table that's further up the chain that was one of the first ones to go might have some data changed or added after the fact. However, if you have the replicates active, it'll take that new data and you'll be good to go and you don't have to worry about this. So replicating everything. So this is, I want to go ahead and make sure that everything on our system is replicated. So this previous slide was basically the overall higher level, these are the steps you need to do, and then you have replication up. This is actually going a little step above, which is actually setting up the steps. I apologize. Apparently these two slides got swapped. I will fix that before we post it. So the steps to actually get replication going to do everything is set up the trusted host, use CDR define server to set up the initial system. You set up then the secondary, join it to that domain, make sure all your tables have primary keys or your keys, and then use DB schema on your old server to pull the schema for any databases you're bringing and just run that schema against the new server. That's usually the easy way to do it. Obviously, this is a good time if you're making changes to changing extents, changing indexes. Now's the time to do it before you start loading the data. So keep that in mind. Just after you've pulled the DB schema, that's when good time to review if there's any changes you need to make. So replicating every way. I had a comment here. Be careful not to. Actually, this is a very good one, and thank you for Michael for mentioning this. Make sure to load the DB schema the same user that you exported it as, and make sure the table ownership remains the same. Be aware that if you're to create the database as one user, there is no easy way to change that ownership. So what will happen is when you've gotten the data loaded, you've migrated everything, only then will you realize things that may be referencing the database owner name or the default name when new objects are created. It's suddenly coming up as the wrong user, and now some of your scripts are breaking or otherwise not working as you're expecting because the owner is different. So thank you for that reminder. So I promise I proofread this, as I was doing the final changes on this, and it's more than one way to do this, but I am showing a simple way to do this. So this is a cheat sheet here for basically setting up replication for everything. I will show a version 14 way to do this. It's a bit cleaner, but if you're running prior to version 14, here is kind of my cheat sheet on replicating a full database. So go into your database and actually put in the following statement. Unload to replicate.sh, select tab name owner from systables where tab ID is greater than 99 and tab type is T. So what we're actually doing here is unloading to a file called replicate.sh, unloading every table name and the owner name from systables where it is not a system table and it's an actual table. And it will create a flat file that just has pipe delimited tab name owner. Then the second part is on the command line, and I give a Perl one-liner here. Obviously, there is dozens of ways in Unix. I know there's plenty of ways in PowerShell on Windows to do this. I just like my old Perl one-liners. But basically just doing a find replace effectively and changing creating the CDR defined REPL for each of those tables. This is assuming we're doing primary target base because it's got the P and the R. And so what it does is it creates the CDR defined REPL command. This is setting up for always because it's target, so we aren't going to deal with conflict resolution. The last thing is it actually has a new line there, and then CDR start REPL, and then the REPL name. And so after you run that, you'll have a big list here for each table in your database. It'll actually say, CDR defined REPL, pointing to the old from the old server to the new server, and then for each one of those after that, it'll start them. There's, again, lots of different ways to do this, but this is just one here for reference. So at this point, we've run that command, we've got our replicates, we've executed that shell script, it's now created the replicates for every table in our database. The next thing I would recommend, and this is just personal recommendation, you can create a replicate set, which is just you give it a list of every replicate you want it to be, and then you can run commands on that replicate set, and it'll be run on each of those replicates. You can still obviously run things against individual replicates as well. It doesn't overwrite your ability to do that, but it just gives you then the ability to do some things as a single command. So if you need to pause replication, you need to start replication, you want to do a check repair on everything, it gives you a single set. It's just a making your life easier going through this process. Now the second thing is then you start looking at the CDR sync. So the CDR sync will do the initial copy of any records that are not there on the target. So this is primarily recommended if the target is empty or at least does not have any of the rows coming from the source system. That's really what it's meant for. This will work with any data types that are replicated. So again, this will work with your smart blobs, your dumb blobs, your time series, etc. So it's a really good way to migrate your data in a fairly easy, keeping yourself sane sort of way. It's as simple as CDR replicate -M to tell it the master server, -R to tell it the replicate name, and then the target server or servers. You can have multiple targets for a replicate, so if you wanted to have your primary server and a test server set up at the same time and kept up to date, it'll let you do that. So as we said, use the methods to copying an initial data set. Use the methods we just talked about with the sync, set up all your replicates, but you may not want to start the replicates yet. In this case, what we want to do is actually use other tools to copy the data. So what we want to do is actually, let's say we have already restored from a backup, we're using SQL copy, we're doing unloads to external tables, again, see Mike's migration thing for a whole slew of different options. And we've loaded it up into the target system. So the target system is now out of date from the primary, but it's got 90% of the data, 95% of the data. Maybe it has almost all of it, but there have been changes that day. All depends on your data set, your environment, what the load is like. The key thing is here, you want to set up your replicates, but don't start them. The last thing you want to do is start sending over new data when the data between the point you took that backup and now has not yet been inserted, updated, etc. ER will still run, but you'll start getting a bunch of errors where like deletes will occur and it'll say, record not found, or it'll try to update records that don't exist, or maybe it's updating rows that have the wrong data. We don't want to have to start getting a whole bunch of errors put out, and I've seen on some production system where it can be logging out thousands of errors a minute if the system is busy enough and a significant set of data on the target does not exist. So don't start the replicates yet, or go ahead and start them, then stop them. ER lets you do it how you want to work it. But what you want to do is actually get the replicate going when you're ready. Start that individual replicate and then run a repair on it. And I'll show the repair command. It's on a future slide. And what that'll do is it'll go through, do a checksum of the old system, the new system, see any rows that have been changed, any rows that have been inserted, deleted, whatever, and will then adjust the target to look exactly like the primary system. So once you're done with the repair, you'll have all your data. It'll catch up that last little bit. And the thing is, if your ER goes down for whatever reason, and not in a way where things are queued. Let's say it exceeded the queues, something bad happened, whatever, life happens. You can still go in, reset up the replicates and resync, or sorry, re-repair, and it will catch it up and you'll be ready to go. So it is not something where all is lost if everything goes wrong. This is a contrast to HDR, which if one of the systems gets out of a log chain, you have to do a new backup, a new restore to that secondary, and then bring it in line with the primary, which can take some time. ER will let you catch up and be very flexible. Obviously, though, because it does have to do a checksum on large tables, this can take a while, and especially if you only have 10% of the data, this can take quite a while to copy over because it's doing them one row at a time or one set at a time. So I've talked about trickle feed. I have a couple of just kind of random slides here just to follow up on a couple of things. So trickle feed, which I discussed earlier, it's really useful for migrating slowly and especially if bandwidth's at a premium. You may be moving to a new data center. There may be heavy loads during the day that your bandwidth, and whether it's your network bandwidth, your IO bandwidth, whatever the bandwidth may be, you may not want it to, constantly dealing with all the ER copies during the day or during particular load times. So you can set up trickle feeds to, you copy the data outside on your own schedule, or schedule it so it only replicates during certain hours. Again, this is the same method we talked about before, where you have an empty database. You copy the data however you want, and then you just send the data over as it needs. So repairing records. So you use the CDR check repair command. This was introduced in version, I believe, 11.7. 11.5. It was improved upon in 11.7. There are certain limitations on 11.5 if you're using it, and if you're running any versions older than 11, it may not support it, or, helpful hint here, there is a checksum stored procedure out there on newer versions that can be added to older versions and will allow check repair, but obviously this is not officially supported, and I would not trust a production environment to that, but it can be set up that way. Regardless, largely a check repair is aimed at 11 and later. Which is also the fact it is not officially supported, so I don't have a slide about it, but reason to listen to the webcast. So it can be slow if you're not using shadow columns to speed up. I'll talk about those in a few. It'll go through, run a checksum store procedure against every row of data to get basically a checksum unique identifier for what's in that row. And if the two rows don't match between your originator and your target, it'll go ahead and copy over the row to make sure it's up to date. So even if you've done a small change to the row, it'll still copy it over. So keep that in mind, especially if you have large row sizes, that this could take a while. By default, and I want to highlight this, it'll delete rows that are missing from the master, so delete them from the target. And so if you put a bunch of test data on, then you do a repair, it's going to get rid of all those test records. There is a flag you can pass that'll leave the target rows if you want them to remain. All depends what your environment, how you want to do it. You can also use a where clause. So if you know that there's only been new records where the timestamp is within the last week, you can pass a where clause to the command to actually say where timestamp is greater than 1 week ago. So you can use that to limit down what it's actually looking at, which can be really helpful for large tables. It also can let you chunk up the repair jobs so that they are limited in time. So you can do maybe, where only 1/3 of the table at a time during your off-hour windows when the system's going to be less busy. It all depends, but as I said, with ER, they give you lots of options. So CDR check repair, just, you at the master server, you pass it the R if you want it to repair, the big R. If you do not have the uppercase R there, or I believe it's -- repair, it will print out the different counts, but it won't actually repair anything. Then you pass it the replicate and then any of the target server or servers that you want it to go to. If you're using update anywhere and you have more than 2 servers, and especially if you're using the timestamp conflict resolution, you can actually, rather than passing a target, is tell it all, and it'll just automatically go and replicate, make sure that between every system you have, every row is up to the latest version and go all directions to make sure every system is identical. Also, if you're using large objects that do not change, that can be a thing. If you may be changing data elements, but the blob, clob, the text or byte field has not changed. You can actually pass the -- skip lob, and it will bypass scanning that object for the checksum. We've done some tests on this. In one of our test environments, it sped it up by about 50 times. It was taking, it took a repair that was taking about a day and a half and took it down to about a half an hour. Some we actually saw more than that, just because if 90% of your data is sitting in those blobs, it'll skip all of that, make your life easier. So connection manager, I just want a quick slide on this. I'm not going to go into too deep on there, but again, we've had webcasts. There's lots of information out there about connection manager. It is a great utility. I think everybody should use it. But what it does is it lives in front of your server or servers, acts as a middleman for connections. But for migrations in particular, it's super helpful, because if all your applications are pointing to a connection manager, use enterprise replication to either cut over or even run both in parallel. All you got to do is update your connection manager config to tell it to point to the new server. Don't need to change anything as far as your application. You don't have to go in and change everybody's ODBC settings. You don't have to do any of that. All you have to do is just fire the change on connection manager and push it over. And even more so, if you're using enterprise replication and you decide you want to run both systems in parallel for a while, some people want to do that to check, and you're running update anywhere on every table, then both systems are totally in sync until you're ready to cut off the old one. ER will let you do round robin or even load balanced. So it let you just send, replicates around as you need to between the old server and the new server. So you actually spread the load and kind of do a slow migration over. You can also set up ER listeners so that one listener goes to the new server, one goes to the old one, and just when you're ready to cut over, just you change the one that points the old one to the new one. Now everyone's over there. That's a good way so that you launch one group into the new server before you launch your whole application or your whole team or whatever it may be. So it gives you a lot of flexibility without having to go back and go to everybody's desktop and modify ODBC settings or push out a big package change or something else. That's the last thing you need to be dealing with when you're trying to check all of your data, make sure your data works, your applications work, everything else that's occurred on your migration. It's one less thing to have a headache over. So, new feature in version 14, CDR migrate server. So, you need to have your target server be version 14. Your other server can be 12 or 11. As far as I'm aware, it would not support 10, 9, or 7. So what it will actually do is the parts we've talked about previously with creating the replicates, setting them up, doing the syncs, making sure the data is copied. This will automate all of that for you, and it lets you configure it all as you go. So what it actually does is defines the domain. So this is the ER domain of what servers are in there. It's usually between your primary and target. It'll go through and add ER keys to any tables without a primary key or unique index. Be aware, if you have a large table, this can be fairly time consuming. The reason for this is ER keys are shadow columns. They're extra columns tacked to the end of a table. So if you have your table set up so it's using most of a page, suddenly if you add that extra ER key for it's a unique value to the end of every row, it may push it to a new, one of the rows to a new page. If you've got a billion rows in the table, that's a lot of data that is now shuffling around and a lot of pages that are being moved around. If you have really large tables without a primary key or unique index, I would really look at, and do you want to use ER to do a migration? I would really look at having a separate process to add in a primary key or unique index in advance. Or if you have to use an ER key, just plan for some extended time while it is building. You need to have storage spaces for ER, specifically a smart blob space, and usually a good DB space that the syscdr database can live in. If you do not have them created already and you do have a Informix storage pool set, the CDR migrate will set it all up for you, so you don't have to think about it. But again, you need the storage pool there. But they're doing more and more work with storage pools, so if you don't have one already, it may be the time to start looking at setting one up. It'll create your target database, create your replicates, and then go through and synchronize the data between your servers. So the goal of when it's done is you now have your target server looking exactly like your primary. So prereqs, again, both servers must be trusted and most must be able to communicate back and forth with SQL hosts set up on both sides. Again, if you want it automatically setting up storage space for you for ER, you need a storage pool for it to be able to pull from. So again, as I said, make sure there are keys on every table. A couple of notes, and I've been told these may be adjusted in the future, but currently as of 14 XC1, it does not support time series between Informix versions. If you're moved from one 14 system to another, it'll support time series, but if you're coming from 11.7 up to 14, it will not currently. It also does not update the starting serial value on target tables. Just be aware of this. So if you have a bunch of gaps in your table, it'll start back on an earlier ID number in one of the open areas once it starts inserting records again, unless you manually go in and actually update the starting serial value. That is just a notice that I was given about the tool, so just be aware. So it has what are called phases. These are the different steps. You can run them all together, which is the final one here, or you can run them one at a time. So you can go through and only do the ones you need. And if you run into a problem with one, you can go back and fix it and then run it again. So defining the ER, which is setting it all up, adding ER keys, so that'll go through, inspect the whole database, add ER keys where needed, create the spaces. This is pulling space from the storage pool to create the smart blob spaces, create the schema, which is actually using the db schema command to copy your schema across. Just be aware if doing this step, it's expecting your DB spaces are largely the same. So if you've changed things up on the new system, you'll probably want to do this step manually so you can then point places to new DB spaces where needed. Then it's to create replicate set, create replicates. So it creates the replicate set, and it actually will create an ER grid on top of it all. And then sync data. This is the actual data copy, depending on how big your system is. This can obviously take a while, but it will not stop your primary system. This may slow it down a little bit because obviously you're reading a lot of data. It's not going to lock anything. It's not going to prevent you from doing work. You can do this during the middle of your business day and it won't break anything. Again, it'll slow things down, so plan accordingly. So a note on, so that's what I have for CDR Migrate. Again, it's a brand new feature. Haven't used it in the wild yet, but I wanted to highlight it in case anyone's going on to 14, because I know a number of people are looking at migrating now. It can be a really helpful feature to simplify moving over. So a couple other notes here. Shadow columns, which I mentioned a few times. There's 3 with ER. ER key is the biggest one. This is availability to add a unique key if you don't have a primary key or a unique index. Again, on a huge table, hopefully you have a primary key or at least a unique index. On Often where I find a hierarchy is really helpful is if you've got tables where you've got 10 rows in the table, or it is just one field. Something like that, it just can be easier to add a hierarchy than to have to go through and maybe add a serial column or something else. The next, and I actually recommend looking at all three of these if you're looking at doing this. The next one is CR calls. So this is actually used to track changes to the row. So anytime a row is updated, it's got a little timestamp field that it marks on it. If using timestamp conflict resolution, you need to have CR calls added to any tables you're doing this on. And I do recommend you look at timestamp conflict resolution if you're doing update anywhere. So if you want both your primary and your second and your new system and your old system to be in sync, you want to run them at the same time. I'd really look at adding CR calls to it. The last one is REPL check, and this can be really helpful if you're looking at doing large tables where you may be doing a trickle feed, or you may be preloaded, or just gonna sync up or repair in the last few, or maybe you're doing something else and you just need to clean up a table. What REPL check does is adds a checksum field already pre-calculated to each row on the database. So when it's actually doing the REPL check or the check replicate, it'll actually go through, use that field instead of having to calculate on the fly. So it is much quicker to do repairs. Obviously, it still need to copy any records that are changed, but if you've got a large table, this can make it much quicker when you need to do repairs. With the shadow columns, again, it adds a couple of extra fields to the end of the table. You will not see these fields if you do a select star from, but you can actually query them directly, sort of like with row ID. You can also, you will see them if you do a DB schema. So adding shadow columns is pretty easy. Alter table, table, add, and then the type of shadow column. So failback. This is the one other part of migrations that is often overlooked, and this is what happens if it doesn't work. What happens if you find your application, 3 days into your, or what happens if you find your application doesn't work correctly once it's in production? What happens if you found your DNS is totally broken? What happens if you find that there was something that was just simply missed in your migration process and everything's on fire and you need to go back to the old system? This is where having the ER replicates can be just a lifesaver. One of the the simple ones is the new server doesn't come up. You do a reboot test after the data's there. You want to make sure, and just the whole thing, it doesn't come up. Somebody messed something up. There's something that's a problem. Everything crashes. Nothing works to get go. You just go back to the old system. No harm, no foul. Sort of fail back. Those are pretty simple because nothing was written on the new server. It never went into production. You've just lost the time for the migration, but you schedule a new outage window and move on with life and fix whatever the problem was. The scariest situation is 3 days into your 3 days after the migration, everything's been running on the new server, and suddenly there's a problem. Somebody had something in the wrong table. Somebody that one of the applications wasn't working correctly. Something was writing, something was set up wrong on Informix. One of your zealous sysadmins, decided to reuse that extra bit of space at the end of the disk, which just happened to be raw space, raw DB space. Something bad happens, and now everyone's screaming, and you need to fail back. There is not the time, there's not the ability to just recover from where you're at. If you have been using ER, you can have a solution for this. So if this is a viable option and you have update anywhere set up, you point everybody to the new system, just leave the replicates in place for a few days. Obviously take backups, so you got clean backups of everything, but just leave them running. If you have every table in your system with update anywhere, everyone's running to the new system goes away for whatever reason, just point people back to the old system. It's got all the data. You're good to go. You're dealing with, a few minutes to push people over, and you have now been the hero that everything is there. Same thing is if there's some kind of disk corruption. Again, the situation where somebody reuses raw space that and suddenly turns into a file system and you start getting data corruption on disk. I wish I could say I've never seen it happen. I've seen it happen. You still have all that data written on the old system. You could even recover the new system based on the data on the old system, or you can go ahead and fail back over. You've got all of your pieces there. If you're doing single target direction replication, what you can also do is after you migrate, after you push things over to the new system, is flip the direction of those replicates, rebuild them all pointing the other direction. So you're now doing a feed of data from the new server back to the old server. So any data that's coming in, you've still got then on the old server if you need to fall back. That way your old server is ready to go. And even if you don't actively have them, you don't actually have the replicates at time, let's say the application server pointed to the new server suddenly stops working and you need to fail back. You can always set up the replicates at that point, use the repair job to catch the old server up with any applications and any transactions or anything else that has happened to the database since the migration occurred. Number of ways to set this up, but ER can be really, really helpful just to have that little peace of mind of, hey, if everything, goes wrong on the new server, we've still got the old server, it's still got all the data, it knows everything, and you're good to go. The last thing to be concerned about is if you're worried about data corruption on the SQL layer, you're worried about, what happens if the tester still pointed to the production system? What happens if the job that was running against it to clear up data now misfires and deletes a whole table? You can actually use the time-based replication if that is your concern. You could set it up so that it only replicates back to the old system at night. Think about having it set up so that at 10 p.m. at night, it goes through and does all the replication at that point. So replication's running. It's taking all the new transactions, putting them in that smart blob space for ER, and then at 10 o'clock at night, it sees the window clicks open, and it'll send all those transactions over. What that means is if something goes wrong on the production system and bad data is put in, you've got until 10 o'clock at night to shut off the replicates and pull the good data on the old system. So you've got basically you've got a running restored backup server as of 10 p.m. or 11 or 12 or whenever the window shuts off for the restore from the night before. So you've always got a fairly close to up-to-date server in that case. It's another option, don't have to do it, but it could be there if you need it. And again, ER can have multiple targets. You could have one system that's kept live up to date and one system that's updated nightly. So you've got two different levels of failback if you need it. So there's a lot of different options. So a couple of downsides to ER. The first one is not as fast for actual large-scale data transmission as backup and restore or other binary methods of moving data. Because it's having to do everything in ASCII format and in SQL format, it takes longer. I did a check, and it is longer than straight SQL copy. I tried some tests earlier. Is comparing best case to worst case scenario where it was doing an SQL copy, how I would do it on a data migration of moving it to a raw table, everything disabled. Moving 16 million records took about a minute. I then compared it to running how I would do an ER where I had it set up so it was logging, the index and constraints were on the table, using the sync command, it was taking 20 minutes. That's a little bit of an extreme example, and this was not a terribly well-tuned, but it's to give you an idea. I've done several other tests, and sync is usually slower than straight SQL copy, but again, sync will not let you do smart blobs. Sync will not give you up-to-date data. It'll just give you as of the point where that command finishes. There's a lot of things it doesn't give you, which is why it is a little bit, or one of the reasons why it's a little bit faster. So it is a trade-off, and it all depends on your environment and your timing. Hopefully you're planning your migration months out, and if you want to use ER, you could start data copies months out. Start moving the data over in small bites, just as, whenever you have time, and, you don't have to worry about doing some huge sync, the day of the migration. All depends on how you have your environment set up. Other downsides, again, doesn't work with unlogged systems. If you're just dealing with unlogged system, can't help you, but would really recommend, if you at all possible, look at changing it to logging. It may save you someday. If you're going from vastly different versions, let's say you're migrating from version 9 to version 14, check the docs for any notes, just to see if there's anything that you might run into jumping between the two. One of the big, common ones might be reserved words. That might be, just like if you're to do an upgrade, running into reserved word problems when creating the database. But just make sure if you're using any of the not as standard data types, you're using UDRs or things like that, check your notes on it. And again, because it's asynchronous, it is not guaranteed to be real time. There's going to be some lag from when the record is written to on the main system to when it is written to the target, because it has to basically take that SQL command, put it into the queues. The queues are then shipped over. Queues are then read on the target side, and then the SQL is run over there. So if you have a good network connection, both systems are relatively fast, it'll be effectively real time. But it is not like HDR, which is, if you're running in synchronous mode, is guaranteed that the secondary will be exactly the same as the primary. So just keep that in mind with doing a cutover, that you may want to bring if you're doing a cutover and you have to have absolutely no lost transactions during that period, you may want to bring the old server into single user mode or something like that for a minute, or at least until the send queues are cleared, just to make sure nobody is writing after you do, if you're actually cutting off replication. So that's just one other downside. If you have any questions, feel free to put them in the chat box. So upcoming webcast, our next one is Thursday, August 29th. It's Lester going into some deep dives into indexes, both of, the high level of what is an index, but actually going into when you'd use them, what are the different types, and when would you use the right ones. So there should be some really interesting stuff. Again, it's advanceddatatools.com, Informix, and next webcast, or just go to the website, it'll be on the front page. We've got upcoming training, and we've updated our materials for 14.1. Our next one is our Informix for Database Administrators in October. But if you have particular training needs outside of that particular class or that time frame, contact us and we can talk about what we can do for you. Again, we have updated training servers, so every single student in the class, whether they're there physically or they're doing remote training, they'll have their own server, their own physical server. We're not making everybody dealing with virtual systems, running either 12 or maybe moving up to 14. Each one has 8 cores, 16 gigs of RAM. We're working on both SSD and traditional spindle disks, so you can get a pretty good idea of different ways to tune and set up systems on different environments. Information about us. We do remote DBA support. We do performance tuning. We do training, consulting, development. If you need Informix work, we are people to come to. We have huge number of IBM Informix champions. We have some of the most skilled Informix DBAs out there, and we are available if you have any needs. Feel free to contact us, and feel free just to contact us and talk if you're not sure. Okay, and I got a question here. CDR sync rep will pick up where it left off. It generally, as far as I'm aware, it'll basically start anew if you have to restart it. Hopefully at that point, it has gotten to the point where you can just do a repair to catch up the rest. But let me double check the notes on that, because I don't want to give you an incorrect answer on that one. So I will reach out to the person that asked that and put a note on there. Anyone else have any other questions? So thank you all very much for being on. Thank you all for those that are watching this after the fact. For those of you that are on live, I'm going to be updating a couple of slides where I realized I had those 2 slides swapped and a couple of typos. So once the slides are posted, you should see the corrections there. So I apologize for those little oversights on my part. I double checked it and apparently should have tripled. So thank you all again very much for being on, and hopefully the rest of your days are great.